In the name of Almighty Allah, the most merciful and the most beneficent. Well, students, a very warm welcome. In this session of week 4, I am your physics teacher Habibur Rahman from Garrison Academy Junior Campus, Kushamala, Kent. As you all know that in the previous session we have discussed about Vernier Callipers, the parts of Vernier Callipers, how we can take measurement and reading by using Vernier Callipers. In this session, we will focus upon micrometer screw gauge. We will describe the parts of the micrometer screw gauge. We will discuss how we can take measurement by using micrometer screw gauge. In these pictures below, you can see that this picture is of digital Vernier screw gauge, digital micrometer screw gauge, and the other two pictures, this one and this one, these are not digital. Taking reading by using digital micrometer screw gauge is easy, while from other two micrometer screw gauges which we mostly used in our laboratories, this one and this one, we use these micrometer screw gauges in our laboratories, and by the use of these micrometer screw gauges is to measure or to take the reading of some specific substance which is not so much thick. Like you can say, if you want to measure the thickness of a wire, you can use the micrometer screw gauge. If you want to take the reading of the diameter of a sphere or a small ball, then you can use micrometer screw gauges. In short, you can say that if you want to take short readings, small readings, then these micrometer screw gauges are used mostly. Now come to the major topics which we will discuss in this session. First one is we will discuss about the parts of micrometer screw gauge. Then we will discuss about the least count of micrometer screw gauge and how you can measure or take the least count of any instrument of micrometer screw gauge. Then we will discuss the instrument errors. Then we will discuss that how we can take reading. Keep this thing in your mind. All these things are very much important, because if you want to take reading, you must know about the parts of the micrometer screw gauge. You must know about how to find the least count of this instrument. You must know about that what are the instrument errors. Now first come to the main parts. Here you can see, if you will start from the left top corner, this one is anvil, this one is spindle. This anvil is also called stud. This anvil is also called stud. Stud is another name for anvil. Come to the spindle. This one is spindle. You can see this one is spindle. This one is a lock nut. If you want to lock something here inside the spindle and the stud, then, and if you want that this spindle stud must not move, then you have to lock it from here. This is the main scale, or you can say sleeve. This one is the main scale. I am putting a line over a main scale. This one is the main scale, and this one is the circular scale, or you can say micrometer scale. This one is basically a circular scale, C.S, circular scale. And this one, which I told you, this one is basically main scale, M.S, main scale. This one is the thimble. You can see this one is the thimble. This one is a ratchet. Here is a ratchet. By rotating this, you can move the spindle in and out. You can move this spindle in and out by rotating this ratchet. Now this one is the frame. Here you can see this one is the frame. Baseline. In the next slide, when we will start reading here, the picture is not so much clear, but in the next coming slides, I will tell you about baseline. Baseline is also called index line. It plays a very important role in taking measurement by using Vernier calipers. This one is also called index line. Okay, here again main scale, which I told you before, the above, and that's all from the parts. Now in this slide you can see that we will find the least count of micrometer screw gauge. Here you can see two pictures, this one and this one. In the previous slide I told you that I will tell you about the index line. Now I am moving this pointer over an index line. You can see here, this one is the index line. I hope you are clear about index line now. This one is the index line, and these are the numbers which are highlighted on an index line. This portion will be called as main scale, and this portion is called circular scale. It will rotate like this. In this picture you can see that the circular scale is rotating over a main scale. If you will move this ratchet, if you will rotate this ratchet in an clockwise direction, it will move forward, and if you will rotate it in anti-clockwise direction, the circular scale will move out like this. For finding least count of micrometer screw gauge, we must know about the formula of it. Pitch of the screw gauge divided by total number of divisions on circular scale. Every micrometer screw gauge has different pitch. What is pitch? Pitch is basically the smallest distance between two divisions on a main scale. And if you will talk about the technical definition, it is that when we will rotate this thimble, and after completing its one rotation, the spindle moves 1 millimeter along the index line. When the thimble will complete its one rotation, this one is the thimble. When it completes its one rotation, then the spindle moves. This one is the spindle. This spindle moves. How much it moves? It moves 1 millimeter. It moves 1 millimeter. This means when, I am repeating it, when thimble completes its one rotation, and after completing it one rotation, this spindle will move 1 millimeter along the index line. This one is the index line. This whole, the spindle will move 1 millimeter along the index line. This is the distance between two consecutive threads on the spindle, and this is the distance which we call pitch of the screw gauge. This 1 millimeter will be called as pitch of the screw gauge. But here sometimes the distance between two consecutive threads is 1 millimeter, and sometimes the distance between two consecutive threads is 0.5 millimeter. Here I want to tell you something, that if the number of divisions on a circular scale, this one is the circular scale, if the number of divisions on a circular scale will be 50, then the pitch of the screw gauge will be 0.5 from here to here. If the number of divisions on circular scale is 100, then the pitch of the screw gauge will be 1 millimeter. In short, you have to check it. When you will hold micrometer screw gauge in your hand, you have to check it. When you will rotate the thimble and you will complete one rotation of it, then you have to check how much spindle moves. Either it moves 1 millimeter or it moves 0.5 millimeter. You have to check it. Then you will use this formula to find the least count of micrometer screw gauge or the least count of that particular instrument. I am repeating the formula: pitch of the screw gauge divided by total number of divisions on circular scale. Now in the next we will discuss about the instrument errors which a micrometer screw gauge mostly have. Here you can see there are three types of errors which any instrument or any micrometer screw gauge can have. First of all, come to this first picture. Here you can see this is the index line and this one is the circular scale. When the spindle and the stud will come into contact, in this situation, if the index line is meeting with the zero of the circular scale, this one is the index line. If the spindle and the stud will make a connection with it, keep this thing in your mind. There must not be anything between the spindle and the stud if you want to find the error of an instrument. And the spindle and the stud must be in contact with each other. There must not be anything between the spindle and the stud. And when they will be in contact with each other, then you will see whether the index line is accurately meeting with the zero of the circular scale. If they will meet with each other like this, then you will say that there is no any zero error in an instrument. Now come to next. By making a contact between spindle and the stud, if the zero of the circular scale is below this index line, then you will say that this is a positive zero error. And if the zero of the circular scale is above the index line, when the spindle and the stud are in contact with each other, then there will be a negative zero error. I hope you get the concept of it. Positive zero error and negative zero error. In this slide, students, we will discuss about that how we can take measurement by using micrometer screw gauge. Keep this thing in your mind. There are three main basic steps by which you can easily take measurement by using vernier calipers. First one is you have to find the zero error and its correction from the instrument. Then you have to take the reading and then you have to make a correction of this reading. You will do a correction of the reading if there is any zero error in an instrument. If there is no any zero error in an instrument, you will just take a reading by using micrometer screw gauge, and you will just do this middle step, observed reading step. And if there is any zero error, then you have to follow all these three steps. First of all, let's suppose there is a zero error in an instrument. The formula for finding zero error in an instrument is main scale reading plus circular scale reading. Keep this thing in your mind. Whenever you want to find zero error in a micrometer screw gauge, you have to close the spindle and the stud. When you will close and when the spindle and the stud will make a connection with each other, then you will take main scale reading and the circular scale reading for finding zero error. In the top right picture, you can see this is a picture when the spindle and the stud is in contact with each other. In this picture, you can see the index line is not coinciding with the zero of the circular scale. So there is a error in an instrument. As the zero of the circular scale is below the index line, so the error is positive. How you can find the zero error? You have to see the formula main scale reading plus circular scale reading. Whenever you will find main scale as zero error, the main scale reading will always be zero. In finding the measurement by using vernier calipers, you will take readings in millimeters. You can also take reading in centimeters, but as far as our book is concerned, they use the reading in millimeters, so we will also follow the book. As far as circular scale reading is concerned, the formula for circular scale reading is circular scale division that coinciding with the index line multiplied by least count of micrometer screw gauge. Here in this picture you can see the circular scale division which is coinciding with the index line is the third division. This one is the 0, this one is 1, 2 and 3. Third division is coinciding with the index line. So here we will write 3 multiplied by the least count of the micrometer screw gauge in millimeters, that is 0.01 millimeter. After calculation you will get that the answer is 0.03 millimeters. I put a positive sign here because the error is positive. As the error is positive, so correction will be the negative of zero error. So negative of zero error will be minus 0.03, or you can just put up opposite sign of error. If the error is positive, then the correction will be negative, and if the error is negative, then the correction will be positive. After finding zero error, we will move towards the reading, that how we can take or find or measure something by using micrometer screw gauge. For this, let's suppose there is something between the spindle and the stud. Let's suppose you can see in the below picture I draw this sphere. Let's suppose this is a sphere. I put it in the spindle and the stud. I just locked it, and this circle shows you the scales, the main scale and the circular scale, and this bigger circle gives you the magnified view of this smaller circle. So we will discuss and we will take reading by using this magnified or bigger circle. First of all, come to the formula. Observe reading as is equals to main scale reading plus circular scale reading. This formula is same like zero error, but here how we will take main scale reading, we will see that in this we will see the main scale, and for taking reading from circular scale we will see the reading from circular scale. First of all, come to the main scale reading. Here you can see this is 0, this one is the 0, and from this 0 to this line, this distance is equals to 1 millimeter. Keep this thing in your mind, 1 millimeter. From 0 to the next division, the distance is 1 millimeter. Now I am using a laser pointer so that it will become easy for me to describe you. From this 0 to this division, this is 1 millimeter, and from this 0 to the middle division, this is 0.5 millimeter. Keep this thing in your mind, 0.5 millimeter. Okay, 0 to this division 1 millimeter, then 2 millimeter, then 3 millimeters, then 4 millimeters, and here you can see you can see that there is a division of 0.5. Here this is 4 millimeters, and just after 4 this is 0.5, it will become 4.5. So the main scale reading, or you can say the main scale which is visible to you after putting sphere inside the spindle and the stud, that main scale will be the main scale reading, and that is 4.5 millimeter. You can see in the column, in the middle column, 4.5 millimeter. This is the main scale reading. Now again come to the circular scale of this circle. For finding the circular scale reading, The formula again, you know about it, circular scale division that coincides with index line. Now here you will see that here this is the 10 and the upper will be the 11, then the division, next division is the 12. You can see the 12th division is coinciding with the index line. 12th division is coinciding with the index line. So here 12 will get multiplied with the least count, and after calculation you see that the answer is 4.62 millimeters. This is the observed reading. Now come to the correct reading. As you all know that correct reading is observed reading plus zero correction. 4.62 millimeters is the observed reading, and the correction is minus 0.03 millimeters. So when you will put the values, then you will come to know about the correct diameter of the sphere, that is 4.59 millimeters. So you can say that the supposed sphere which I put here, the diameter of that particular sphere is 4.59 millimeters. I hope this is become clear to all of you that how you can take measurement by using Vernier calipers. Again, I am repeating the steps. First of all, you will find the zero error and its correction. Then you will take the reading. Then you will make a correction of it. For finding zero error and observed reading, formulas are same. That is main scale reading plus circular scale reading. Again, here you can see observed reading is equals to main scale reading plus circular scale reading. I hope now you understand it. In this, I put something in front of you people so that you can easily assess yourself by watching this picture. Just put a pause, press the pause button here and focus over the picture. Keep this thing in your mind that zero error in this instrument is zero. There is no any zero error. Just you have to find the reading by looking at this picture. Here you will see the main scale reading and the circular scale reading, and then you will be able to find the reading. I hope this session will be very helpful for you people. Thank you so very much for your listening.